This video, along with all course content, including laboratory and hands-on activities, were developed by Andrew S. Heinz, PhD, and are copyrighted 2016, 2018, and 2020. All rights reserved. The student's course handbook serves as a guide and as a resource to the student throughout the course. It contains the sample problems done during class, laboratory activities, and practice problems to develop knowledge outside of the classroom. It is available on Amazon. All right, so tonight we're going to be using our super fancy Connects kits. This class is not sponsored by them in any way. We had to pay full price for these, so that's not where I'm going with this. But we're going to be talking about bridges because bridges are a perfect example of what we were just talking about, which is trusses. Okay, so the first type of bridge is the beam bridge or the girder bridge, right? And this is what we were already talking about earlier with our bending example, which is we just take, like, let's say a 2x4 or something like that and lay it down across a creek and walk across it, right? Obviously, those can work pretty well. But what's one of the problems we have with those as they get bigger and longer? They bend, right? We were kind of talking about that, right? So this is actually a perfectly fine example for a short bridge, right? Like, again, if you're going to cross that creek to go to school, probably not a problem. But if you wanted to cross the Columbia River, you probably don't want to use a 2x4. Right? Probably end up in a bad day and a river rescue. Okay, so as these get longer, they start to fail. Increasing the thickness of the bridge can obviously make the material stronger, right? The bigger, like if we use a 2x4, maybe we can't make it as far, but now we go get a big old railroad tie, we can probably make it across the longer span, right? But what's the problem that comes with that from an engineering standpoint? Cost, right? You nailed it, right? Cost. It also becomes harder to manufacture. At some point, you can't find a big enough bridge or a big enough beam, and you start having to combine stuff together to do it. And at that point, you're building a bridge anyway, so you may as well just do it better, right? So it also makes the bridge heavier. And what's one of the problems? See, another one of the problems is as you make these bridges longer, these materials actually start falling apart under their own weight, right? If you were to make a long enough 2x4, eventually that 2x4 would actually bend and break in the middle because of its own weight, right? That's actually, we used an example earlier about the silly putty. Right, what happens to silly putty? We start stretching the silly putty, it gets thinner and thinner and thinner, and eventually it can't handle its own weight and it snaps. Okay? So what we're going to do in our first activity is we're going to look at the short beam bridge. And we're going to build just one part. So this lab activity is in your book, right? And we'll walk through it step by step. But what we're going to do is we're going to build just the deck of the bridge. And we're going to look at what happens to that bridge as we put weight on it. And then we're going to combine activities, and we're going to make that bridge longer and longer and longer. And what you're going to find is that the bridge can't stand up on its own. Okay? So we come to a design problem of this long beam bridge bends in the middle when weight is applied. So what we can do is we can do two things to this beam bridge. We can either push up on it from the bottom, which means we could add another support. And you see stuff like that a lot. Has anybody been to the South, like New Orleans or Florida? They have a lot of bridges like that, right, that go to the Keys and stuff like that, where it's, I don't know, maybe a 300 yard, 400 yard span, and then there's another span and another span, and they just keep going, right? It's enough if they just have a short piece of bridge and then, you know, goes down to the ground, and then another piece of bridge goes down to the ground. That's how they cover the swamps down in Louisiana. That's how they get to the Keys down in Florida. Alternatively, you can also pull up from above. How would we pull up from above? What do you think, Jeremy?
Like some sort of machinery or something. Cool.
Yeah, has anybody seen the Golden Gate Bridge? What's the Golden Gate Bridge?
Suspension bridge.
Suspension bridge. Yeah, it's using, what did you say, Emma? It's using cables, right? It uses cables to pull up the deck, or to hold up the deck, right? Another case we can do, what are we looking at? Truss bridge, right? You can also build a truss on the bottom. Has anybody seen a truss bridge that's on the bottom? They do exist, right? It actually helps to push up, okay? So activity 2, we are going to build what we call a Warren truss bridge, and we're going to look at the differences in our bridge, okay? So if you guys could break up into groups. I have 5 of them, and there are 18 of us, so if I could get 5 groups of 4, please. Find your 4 favorite people, or if they're not your favorite people, then they're going to be shortly. So break up into groups, please. Go ahead and grab some table space. So let's get one group up there, one group back with those gentlemen, one group here, another group there, and then one group over here. Thank you for watching Introduction to Basic Concepts in Engineering. Has this piqued your interest and you want to learn more? Much of the course content and the images in this course are from the text Introduction to Basic Concepts in Engineering for Adept High School Students by Andrew S. Heinz, PhD. While the textbook is not essential to successfully follow all class videos, it is an excellent resource designed specifically for introducing a student considering engineering to the field and for preparing them for the next steps. It contains many additional topics not presented due to time constraints, as well as additional practice problems and answers. The full text is also available on Amazon. Also, find us on Facebook at SHS Intro to Engineering.